fundamentally, it's about clarifying the requirements and making sure that they are delivered correctly. Right. So yeah, so one of my favorite quotes is, "Perfection is achieved not when there's nothing more to add, but when there's nothing left to take away." So yeah, so one of my favorite quotes is, "Perfection is achieved not when there's nothing more to add, but when there's nothing left to take away." Seems to have some feedback here at the moment. Sorry. Seems to have some feedback here at the moment. It looks like we started a little bit late. So I might quickly go over some previous slides. So just quickly, so my talk today is a perspective on how the IT industry is going to change over the coming years based on 30 years experience, and looking at how things have adapted in the past, like as new tools and techniques have come on board. In particular, I've been experimenting with OpenAI's O1 Pro to look at practical uses for that. But I'm doing it from the perspective of having seen how tooling has been introduced in previous years and how this may influence our career development. So AI has a fundamental benefit that is built into the way it works, but it also means it's got an inherent disadvantage. So its benefit is it's able to index a very large amount of information and come up with novel solutions and do complex pattern recognition. But also fundamentally, it lacks a guarantee of correctness because it's extrapolating, it's generalizing information without necessarily having all of the details correct. And because it's generalizing it, it's not completely transparent as to what it's doing. And for this reason, you need to have both context and domain expertise to verify whatever it produces to make it suitable for a professional level. So I was looking for an analogy of how systems have changed in the past as new technology and automation has been introduced. And the closest comparison I could find was about the introduction of ATMs in banking. So there was a fear that when ATMs were introduced, that they would replace bank tellers. And you can see from the rate in which the number of bank tellers were growing in the US, there may have been some slowdown in the growth of the number of bank tellers, but they never completely replaced them. And that's because bank tellers, ATMs were able to do some basic tasks that everyone needed, but they couldn't, they weren't the best way to deliver value-added services. And so, in fact, the number of bank tellers continued to grow even after the introduction of ATMs. So if you look at on the Gartner hype cycle, generative AI in particular, which is what I'm focusing on this talk, is still in the has a peak of inflated expectations. So a lot of people are speculating about what it might do, or they're only looking at it as an introduction, like how quickly can I write a game or a basic website? But obviously, you need to take it further than that for it to be of professional merit. And that's where there's some techniques you need to do to make that practical. And I agree that it probably won't be mainstream for another 2 to 5 years, but it is something that you can make use of today. So who am I? I'm CEO of Chronicle Software. We have 8 of the top 11 investment banks as clients. We have exchanges, hedge funds, and crypto firms as well. We specialize in low latency, event-driven trading systems, and we average around 1 million downloads a month for our open source software. I've also been a Java champion for 10 years now. So a key part of our philosophy is that you go faster by doing less and focus only on what is necessary. One of my favorite quotes is, perfection is achieved not when there's nothing more to add, but when there's nothing left to take away. And in particular, focusing on requirements is a key value and a key way to make sure that your overall project is a success. The terminology in AI terms is prompt engineering, where you have a really specific prompt and you tailor it so that it delivers what you want it to. But I'd say that is really about capturing requirements correctly to deliver the result you want. A lot of the fundamentals are still the same, even with AI. You can continue to build your career to be code-centric and being hands-on rather than necessarily entirely about management. You may move into management and then go back to being hands-on. That's a very common pattern people follow, and I don't see that changing. Another challenge, one of the things that is a bit hard to communicate is the breadth of challenges that you have as a founder, but I'll give you a little bit of a taster further down. But a lot of this talk is really about practical applications for AI today. So one of the things that is hard to appreciate, at least early on in your career, is how multi-dimensional software development actually is. To start with, you really focused on your individual effort, like getting your code to work, what it is that you're contributing to the team, how many lines of code you added. And then you thinking more about, well, how do you work in a team? How do you deliver the technical success of the product? And that's a very important stage to get to. But ultimately, though, what really matters is it successful for the client or the user? Is it delivering to their needs? Does it make money, for example? So some of the most successful IT projects aren't that great technically, but they delivered on what was required in terms of making money or helping that business grow. So you need to have a balanced view of both of these, that the technology is a means to an end, and that end is to deliver to the requirements. One of the things, like as I mentioned, there are a lot of different aspects to being a founder. The key thing is that everything falls under your domain. Everything that's required to run a company, every division that you may have ever interacted of or heard about, all falls under your umbrella. You can delegate some of this, you can outsource some of this, but ultimately you have to choose who does those things. So you have to at least have some understanding of what is required in all of these areas, if not actually having to deal with those directly yourself. Now, this takes a lot of time to develop because to start with, especially if you're self-funded like myself, I started out as a consultant, and then over time grew to having 3 people, then grew to having about 9 people, and today we're around 20. Each of these dimensions becomes more complex as you grow the company. You have more requirements in each of these areas. Fortunately, you have time to do that, but that's one of the things to consider. There's a real shift between when you're focusing on the technical success to running all of the aspects of the business. So how have tools changed in the past? So these are some of the tools that I used to use, going back quite a long way. So at one point, my favorite editor was Edlin, believe it or not. Most people have probably never even heard of it. But in hindsight, it was a terrible editor. You could only edit 1 line at a time, and it took you forever to do anything. And then I discovered Turbo Pascal, which was, by comparison, it's a full screen editor. It was amazing by comparison. I thought it was, it was, I think when I was 17, I told my parents that Pascal was the only language I'd ever need to learn. But yes, very soon after that, I didn't program in Pascal ever again. Then I learned Vi, which in some ways seemed like a backward step, but it gave you a lot more control. And by the time you included all of the tooling that was in Unix, that it was still much more capable in many ways. Then I worked for Sun Microsystems, and they at the time had Forte for Java. And Forte for Java was more reminiscent of Turbo Pascal, but so much more capable. And that became NetBeans. And then by 2004, which I guess, 20 years ago, I switched to IntelliJ. And even though I've used Eclipse from time to time, I've really stuck with IntelliJ ever since. So as I said before, AI is statistical based on enormous data sets. That's their power, but also their limitation. And one of the things that there's a number of things about using it which is different in that that you need to consider that's unlike using a deterministic tool. So a simple example is how you ask the question, how do you query it, what you've even asked it in that context, what information you provided to it will alter subsequent queries. And simple, sorry, before I move into that, some key terms that I think are important to understand before I launch into this is as a technique called human in the loop, which is a fancy way of saying that you need a person to check everything it produces. And if you're doing iterative development, you will check it many times within each iteration. And that's, for me, the most successful way forward, because and I look at what is the kind of error rate you get, and the best way to eliminate the errors is to review it each time. So also fundamentally, the way these AI work is they turn all of the text into what's called tokens. Each token is represented by an integer, and those integers are how it is actually manipulated internally, and those integers then get rendered back into text for delivery. So they're a bit like words, but not literally. So for example, the word unbelievable, GPT-4 turns into 4 tokens. And obviously symbols in code get turned into tokens, and they're not words. Another key aspect of tokens is that each AI has a limit to how many tokens it can manipulate. So the theoretical limit for O1 is 200,000 tokens for its input and output combined that it can be working on at any one time. And it also has a limit in its output of 16,000. However, I've found that, at least for what I've been trying to do with it, you want to keep the input to around 80,000 and the output to around 2,500. I'll show you why in a moment, as in how much it adds with each query is around 2,500. Another key aspect is the concept of temperature. So the higher the temperature, the more likely it is to give out what's called a creative answer, but it's also more likely to produce what's called hallucinations. So one of the benefits of using AI is that it can be somewhat creative, but that means it's also error prone. So lower temperature means that it's going to produce a less creative answer, but it'll be more mundane as well. And less likely to be faulty. So with prompt engineering, that's about tailoring the prompt to guide the context. So a common thing is, say, pretend you're an expert in a particular area, or to give it a very specific instructions on what you want it to do. So to start with, I mean, I had a lot of feedback, from different reviews, though. You need to have a specific prompt. And I've gone quite extreme in this case because I found that prompts for projects tend to work best at around 20,000 words. So that's a lot of words. And I'll show you how I achieve that further down. But that's a lot more than I expected up front, and probably a lot more than most people are using. And fine-tuning is around tailoring those sort of prompts and results. Chain of thought is a reasoning model, so it's not just about generating words, but it will actually reason about what it's producing. And where chain of thought is particularly useful is where it's trying to solve a problem or fix a bug. And I found that it is actually quite powerful at fixing errors as well as coming up with decent initial requirements. So here's an example of what I was talking about how you ask the question changes the outcome. So I was looking for an objective measure. So everything I've talked about is entirely subjective from my, it's just my view on things. I think it's consistent with what other people have said, but I was looking for something objective. And while the size of the result isn't a good measure of quality, it is something you can point to and give a definitive number for. So what I did was I asked it for a user guide for a number of known classes that it already indexed. And one of the things that you can see is that if you ask for the user guide in one go, it generally produces the same number of tokens. And I use the tool down the bottom, which is the tokenizer from OpenAI, to say definitively what is the number of tokens it has. And it doesn't matter so much even how complex that thing is that you're describing. And in particular, interesting one is if you ask it for a class that doesn't even exist, it still produces a similar number of tokens. What you can do is a two-step process. And even with O1, which is supposed to do this internally, it does make a difference. And with a two-step process, you ask it for a plan or a step-by-step plan to produce whatever it is that you want. And then you ask it to execute on that plan. And as you can see, you get significantly more tokens if you do it as a two-step process than if you do it as one. And in fact, the first step, asking for the step-by-step plan, also produces a similar number of tokens. One of the things it does note is it will actually point out that Reasoner doesn't actually exist, and the guide that follows is hypothetical. So I found that it's generally good at telling you whether the entire thing is hypothetical. So if you ask it about something that doesn't exist, or it will tell you that it will produce an appropriate warning. However, where you get errors is where there's some particular fact or point about something that's real. It will tell you some things that aren't correct. And that's where it doesn't give you a warning. So you still need to check all the details to make sure that they are appropriate. So one of the ways to make that easier to spot is I would suggest generating hypothetical results, reading that, and you will see a certain sameness that occurs when you're dealing with something that's hypothetical. So this is the more subjective element. What I did was I asked it to produce a user guide, this time for classes and packages that I had written. So I understood them, and I felt like I'm an expert in them because I wrote them. And so I was able to evaluate the quality of the user guides it then created. So one of the things I observed was that it's a very high rate of producing things that are correct, but not terribly interesting. Like, you probably work this out for yourself. The AI is able to work it out. You should reasonably be able to work it out as well, which sort of makes it questionable of whether it is actually even necessary, because either an expert is going to know this already, or they can ask an AI to generate that information. So do you need to even add this to your documentation, is the question you might ask. Then there's a decent percentage where it's just plain wrong. So it's either irrelevant or complete aside or just incorrect. So it would be better to remove it. And certainly in iterative development, this is a good estimate as to how much you need to remove from anything it generates to make sure that it stays all completely correct. However, there is a percentage that's compelling to keep. That really does add significant value, things I wouldn't have thought of, or extensions that are well worth considering. It doesn't, 5% doesn't sound like a lot, but for each query, on average, I was getting about 2 points that were worth retaining, which for me, for my use case, was a good return, because within a couple of minutes, it would come up with 2 ideas on average that were worth executing on. Another area is when it gets it wrong, but in a way that is interesting. So sometimes it would make a mistake or an incorrect inference, and I think, well, actually, other people might make that mistake as well. And so therefore, it is worth clarifying that that is not the case in the documentation, or in some cases, it would talk about functionality that didn't exist, but maybe should. So in some cases, based on those sort of incorrect assumptions, I've actually gone and added functionality to the code base because that was actually a good idea. It probably should exist, even if it didn't in the current implementation. So this leads me on to a concept that I find is particularly relevant, is a thing called the Baltimore phenomenon. So when you're, what AI does is, if you look in the details, it often determines fairly early in the process how many words it's going to produce or how many tokens it's going to use. And as we saw from the previous query, it has around it often, for a user guide at least, creates around 2.5 up to 2,500 words. And because it starts with that assumption right early on, it doesn't matter how detailed the thing it is that it's describing. It tries to use those words or fill them in. And this is very similar to what happens when you have a map. With a map, you decide what scale your map is going to be and how big is it's going to be. And then you decide what fits into that map based on that size. And so this is a common problem with cartography. And the example being that Baltimore, which is a major city, so certainly its metro area, is very close to Washington, which then means that at a certain scale, you can see both Baltimore and Washington, but then at a later scale, Baltimore disappears. So even though it's got several million people, it doesn't appear in Google Earth at a distance of 1,000 miles. Now, by comparison, you also have a thing called the reverse Baltimore phenomenon. And so again, this is like including, because you've got the space to fill, you've got the words to generate, it starts filling in things that aren't really very valuable or very important or significant. So Alice Springs is often used as an example. It's only 34,000 people, much, much smaller than Baltimore, yet it's still visible on a lot of world maps, because in the center of Australia, there's nothing to overshadow it. So they'll stick in Alice Springs. Now, as an aside, my daughter often has to go up to Kununurra for her work. And she was there a couple of weeks ago and photographed some crocodiles while she was there. But Kununurra, which appears on this map, has only got 4,500 people. And yet it appears at a scale much further away than the point at which Baltimore disappears. So it can show, this is sort of a visual example of how trying to determine what is the relevant details doesn't always map very well when you've determined in advance how much content you want to produce. So the other way to go is just go exhaustive, which in the map equivalent would be to generate a huge map and then decide for yourself which are the details that are worth considering. So if you ask it for a user guide, and I tried this for a number of scenarios, you speaking, you get around 2,000 words. And in that, you get maybe 1 to 2 points that are useful and worth retaining in and of itself. Like you wouldn't have thought of it, or hey, that's a good point. It really is worth highlighting that. And then if you ask it to plan the document and then ask it to generate it, you get more words, but you also get sometimes more useful points as well. Further to that, you can ask it to plan it, and then you can specifically ask it to generate 8,000 words. Now, the reason I picked this number is if you ask it to generate more words, often it will make the decision that actually, no, that's a lot of words. I'm not going to do that. But at 8,000, it generally doesn't complain so much that it's been asked to do an exhaustive list. And it will actually produce that number. And what I found is there's a lot more points to sift through, but you do find more interesting and relevant points that are worth addressing. And you can go really exhaustive, which is that if you ask for a plan, it'll often produce multiple sections. And then you can ask for it to produce 8,000 words for every one of those sections as an individual query. And then that ends up being approximately 50,000, not 80,000 as you might think, but you end up with about 50,000 words. And in amongst that, you can get maybe 12 points. And that's about 1/400th of the entire content. So you have to be quite determined to try and get everything you can out of it. But it can, that is one technique you can use to try and exhaustively try and find, I think the term is mining for gems. So you're looking for those gems out of all of that, all of the fluff that it produces. So is it possible? So what I did is using iterative development, I produced a game as a greenfield project, which I can then open source as well. I've tried this for our internal commercial software, but obviously I can't share that. But I've shared this one, which is a game I've produced, and I've played with some variations on the theme of the game to produce some slightly different results. And there's a link there to it. So how did that go about, and how did I get to like 20,000 words? Well, or tokens. So to start with, I suggest starting with a style guide and some sort of glossary, and that can give it particularly when you're in a greenfield project where you've given it no context, it can help kick off things and make sure they're heading in the right direction. So that will reduce the amount of re-editing you have to do for the requirements, for example, where it starts to produce things that don't fit your use case or your pattern or the way you would like to work. So how do you produce this style guide in the first place? I asked it to generate it and then edited it quite heavily down to only the things that I thought were particularly relevant. So you can ask it to generate a style guide, and then you can edit it so that in future, if you've got a greenfield project, it starts on the right basis. Then you can ask it to generate requirements documents and be as specific as you like. In this case, ended up with around 1,500 tokens being produced in ASCII doc. And so again, starting with the requirements is the pattern that I encourage people do, or start with a plan that you edit, and that way it will you get a more complete outcome than if you just ask it for the result. Then as a single prompt, you can ask it to generate all the unit tests. What that tends to do, if you try and do multiple code blocks in the same query, is that it will give a shorter answer to each one in general than if you ask them all individually. But to start with, it's probably a good thing, because you're really just setting up a prototype. You're setting up a skeleton. It doesn't need to be very complex. After a subsequent iteration, those tests ended up being about 4,000 tokens. On the first run, it was more like about 2,000. And again, for the main code, it was very similar. It started off at about 2,000. In subsequent iterations, it ended up being about 4,000. And so at this stage, I've got, with all the additional files like POM files, it's got about 10,000 tokens. And at this stage, I've not actually written any code myself. It's just been generated. When I run the unit tests, 3 of them failed. And interestingly, I was able to copy and paste just the error message into it. And in each case, it was able to fix all the bugs itself. I've tried this with other examples and it didn't always work, but I would say it has at least a 50% success rate. And at the time, I made the changes manually, but I've since found that you can ask it to update you just say update the documents altered by this fix, and it will give you new copies of all of the files that have been updated. Then I did a round of asking it for suggestions for enhancements, which I placed into a different document. If you look in the project, there's an enhancements.adoc. And through iterative development, more tests failed. So I extended the tests that created more test cases that failed, then got it to fix them. And finally, in adding animations, it's now at around 25,000 tokens. And so that's quite a significant greenfield project. And I think a lot of the time, it took nearly 2 days to do. I would say that it would only take me a day if I did it again, because a lot of it is learning how to use the tools and what is the most effective way of doing these things. So you can actually do it for use AI for even more ambitious things. But some of them, you'll see why they could be quite risky as well. So again, review is very important. So in this case, this is the literal queries I gave it. I gave it 2 queries. One was to create a requirements document for 2 simple programs, just as an example. And then I asked it to write a bash script to create all the directories files and added in that I wanted a readme.adoc. And so this is what it produced. Well, this is the start of it anyway. It produced a bash script that, when run, created all of the directories and also uses cat to create all the contents of all the files as well. So that way, once it's run, it just recreates the entire project from scratch. I've used this in a more practical sense for, I started to accumulate quite a lot of ADOCs, and they weren't all appropriately named. They had poor naming because I was just adding them in. And so I asked it to give each of those files a more meaningful name, and then write a script that would rename them all and rearrange them into a different directory structure. So it created the script. Interestingly, in a lot of cases where it didn't actually change them, it renamed it to what it already was. But nevertheless, as a one-shot script, it was much easier than having to rearrange them all myself. So at this point, it becomes that prompts are more like meta programming in a way. It's a sort of an abstract programming, because you're giving it instructions that are in English, but they're still stylized to trick the AI into generating the code you want. I would say that at this stage, that like any tool, like every tool I've ever used in the past, to start with, you will overutilize it. You'll use it because you don't know what it's good for and what it's not good for. You'll use it for more than what it's good for at some point, and then later realize, actually, it would have just been easier if I'd done this myself. And I think AI is actually quite forgiving in that way, in the sense that what I was doing at some points was I was just editing the code myself, but I was then able to say, supply the corrected code, and then say, update the requirements documents and the unit tests to reflect these changes that I've just made. and it was able to compare what it had previously to what I corrected, worked out the difference, and then it was able to do an appropriate update. So it will help maintain the code even when you're doing a manual adjustment yourself. And at every stage, you want to have version control, and you also want to have compare with clipboard. So I rely very heavily on any kind of output being able to do a line-by-line comparison. And in general, if you're not sure something is an improvement, don't take it, because otherwise you'll end up with a lot of churn. There's a lot of different ways of saying the same thing using different words, and AI will generate all of them. So if you don't think it's an improvement, if you don't think the wording is any better, if in any doubt, just don't take that change. Just stick to the ones that are clearly an improvement, and that's definitely a way to cut down on churn. I favor using ASCII doc as a markup language, but if you don't have a preference, tools like ChatGPT, Markdown is probably more natural. The benefit of a markup language is that you have structured text like formatting, links, tables, lists, and that can be copy and pasted into Grammarly, for example, and then copied back again without any loss of information. So in summary, the one thing that people tend to focus on is the prototype. AI is great at generating a skeleton system with very little effort, as I demonstrated earlier. However, for it to go from just something that does more or less what you want to actually would be useful in production, that's going to be a lot of rework in reality, and you need to be up for that. I would expect that very little of that prototype will survive by the time you get into production, and that you will end up rewriting everything at least a few times. Fortunately, AI is very good at rewriting things, so that doesn't sound as onerous as you might think, but you should go in with the expectation not to be too precious about any of it, and that it will get rewritten, reworked a few times as you go through the development. In later development, you want to stabilize it, so you'll focus more on just updating minimal changes, focus on the quality of the solution rather than adding content. And certainly once you're into production and support, you wanted to identify any gaps, suggest improvements, and keep changes to an absolute minimum rather than generating bulk content. So fundamentally, an expert is still required. It's inherent to the way the tool actually works, and to measures to eliminate some of the downsides to some degree would also eliminate its value. And another way of thinking about generative AI is its peak Dunning-Kruger is absurdly wide red because it's indexed so much information, but has no experience applying it and no common sense. So it has even less experience and sense than a junior developer who's just started, right? So junior developers still have life experiences. AI does not, right? So it will come up with things that are just completely off the wall, but you just need to be up for that. Remove that. No one's going to get upset that if you delete 90% of anything it produces or you ignore the whole thing, and you try again, and it can be very successful. So it can be a valuable tool. So all of the areas that I alluded to before, I would say AI can help you with every one of those aspects if you use it appropriately and with the caveats that I mentioned earlier. The ability to choose the right code is more important than the ability to write code in general. And AI won't change that. So finally, we're on to if there are any questions.
Hello, I'm back again.
Hello, Barry.
I have a question.
Thank you, Barry.
This business about its planning ahead of time.
Yes.
How many words, roughly how many words to use in its reply? This boggles the mind. I'm not sure why it would do that or how it would do that? Does it plan different numbers of words for different queries? And what's going on there is my question.
Yeah, it is a very interesting feature. I think it really comes down to, and I'm supposing a little bit here from just playing with it. It comes down to it deciding in advance how big a map it's going to be. Like it's going to use, for example, you ask for a user guide, it's going to produce around 4 pages of content. There's a recommendation that an article should be somewhere between 1,500 and 2,500 words. And I think it's got a similar sort of idea in its mind that if you ask for a user guide, it should be around 2,500 tokens. And then it starts filling in those tokens as best as it can. And it won't always use its entire budget, but it has a budget that's kind of a bit use or lose, and it sticks to that. Whereas when you ask it for a plan, it ends up producing, it ends up adding another 2,500 words on the second iteration. And you can even ask it to improve it further as another iteration. And in general, I find that it adds about another 10%. It doesn't quite have the same effect that you get here. But yeah, even adding another step again will add even more words that are worth keeping potentially. So I think it's because of that initial budget. Now I've tried gaming it a little bit by just specifying in advance, produce 4,000 words, and you can ask it to do that. But qualitatively, I don't think it produces as good a result. Doing it as 2 steps does produce a better outcome as well, not just more words. If you're up for editing it ruthlessly, I would just start with 8,000 words because that seems to be a good sweet spot. So do a plan and then ask it for 8,000 words and then cut it back. Chop out 80% of it, basically. So you get down to the bits that actually were useful points to keep.
Okay. I'm still in awe of the fact that it does that. I'm not sure why.
Yes.
If I were developing an AI bot, I'm not sure why I would make it that way, but I'm not an engineer of that sort. Okay. Let's go from some other questions. Do you use local LLM or Olama or ChatGPT for your professional activity?
Yeah, so I'm using ChatGPT mostly for the reasoning model. I did play around with 4.0 before and found that while it was pretty cool that it could produce the word manipulation, when it came to producing code, it was just a bit too mundane to even worth playing with. I found that 0.1 in particular started producing code that was actually worth working with. It's still pretty, in my estimation, quite junior in terms of what it can produce, but we don't need really advanced code for everything. Sometimes you just need some code to do something. And 0.1, I think, is capable of doing that. So it's the first model I've seen that's capable. There's been newer models like DeepSeek, which looks very interesting. I've not played with that. But I kind of see it as the first of many AIs that will produce this in the future. And I think they're not very soon. There'll be multiple, not long, there'll be multiple probably local AIs you can run that would be able to do this. One of the things I haven't talked much about so far is Copilot. And one of the things I found particularly interesting is that once you start building up requirements documents in your project, Copilot reads them. This is one of the problems with producing documentation, is that you produce a lot of documentation for your application, but does anyone even read it? And certainly from support questions you get, you're pretty confident that a lot of people don't read all the documentation. Whereas AI does read the documentation. It reads it all. It doesn't have a way of deciding what's important, what's not. And in fact, a lot of the documentation I'm now producing, the target is not another developer. The target is AI, like Copilot, for example. So Copilot reads that documentation and often produces a better result than if you've got decent requirements documents and examples that were built by an AI.
Okay, I just turned off your sharing. Let me know if you wanted to be back on. Another participant says, "What's your opinion on energy consumption of AI?"
Yes, so that it is high. There's some estimate that it's around, I think, around the world, it's around 1% of all power consumption, and
A lot, actually.
it's a lot. So it's likely to go up in the short term. However, if DeepSeek is any indication, it'll probably come back down again. Their energy consumption and training cost was a tiny fraction of O1, and yet it produces comparable results. So I think it's something like 1% of the power consumption of O1 in terms of training its model. So I think there's significant advances in the near future to cutting down the cost of training, which is a big upfront cost in terms of power, and also then for running those AIs as well, and with condensed models. So I think in the near future it will come down dramatically, although it will probably go up in the short term.
Okay. How do you handle sensitive information with AI?
That's a very good question. At the moment, I've handled it by, well, two factors. One is we've got a large open source code base, and so I've really focused on that because it's already public. It's already been indexed as well, which makes my life a little bit easier. I can ask one about my own libraries, and I don't have to provide the same amount of context to it because it already knows all about all those things. So that way, it gives me an opportunity to play with it without actually worrying about that too much. We host on GitHub, so we're kind of trusting that GitHub's going to do the right thing anyway with the appropriate operations. So in a way, we're kind of trusting Copilot, GitHub Copilot, that is. So that decision has already been made in a way. So using Copilot isn't such a concern for me. I'm leaning towards trusting ChatGPT, although I've not really gone down that road much yet, to be honest, because there's still so much to do that's where that's not even a question yet. But certainly, even if you run locally, you would have to do some due diligence to ensure that you're protected, that nothing is going out to the internet if you've downloaded an open source model. And certainly a number of open source models have a built-in bias or something that you might not expect. So for example, DeepSeek has a view of Chinese history, which is compatible with the Chinese government, for example. And that's built into the model. That's not necessarily a problem, obviously, for coding, but it's just something to take into account that these models opaquely can have a bias in terms of which is their preferred search engine, for example, and a number of factors that you've probably not really considered.
Why is Java not used for AI and machine learning models?
I think it comes from the fact that the Python is much more preferred for data scientists, and it's largely been data scientists that have driven the AI forward, I would say, and that kind of area of expertise. And so Python has become a natural language for that, where you're bootstrapping something where most of the computation is all in GPUs anyway. So I think that's where Python with GPUs is actually quite a natural way to deal with AI. However, we're not, for example, even though I'm a fan of AI, I'm not looking to integrate it with any of our products, for example, because of its non-deterministic nature. I'm looking to use it, but not actually run it. And for everything that's not running AI, which in our case is 100%, neither Python nor GPUs make a lot of sense. So yeah, we're still primarily Java.
Have you compared? You mentioned this already, but let me ask again because look at this question. Have you compared ChatGPT reasoning with DeepSeek thinking model?
Only superficially, not in the same amount of detail. DeepSeek, I would say, has much more transparent in terms of its thinking. It gives a lot more detail, and so it is good from that perspective. But in terms of the quality of code it produces, and that's the biggest concern, I'm not sure it's quite there yet. But give it a year, and who knows?
AI grows up.
Oh, yeah, and I think there are some things that will change very quickly in terms of polishing some of the problems. I think there are other areas which won't change so dramatically, and that is AI has had rapid growth in the last few years because it's been able to take on larger and larger data sets. You get larger and larger models. But fundamentally, there isn't more public data to feed it. You get to a point where you've fed it every bit of public information there is, and then, well, that's it. You can't just feed it 10 times more information and make it 10 times smarter. So there is some inherent limits to the way that it works. You can't just feed it exponentially more data to make it exponentially faster. So some things I don't think will improve dramatically in the next 5 years, and other things in terms of usability and integration and seamlessness and things like agents, I think that will change dramatically even over the next year.
All right. Well, thank you everyone for joining us, and please tune into the next J Champions conference session, managing testing data. It'll be on in just 1 minute. Peter, thank you. Thank you.
Thank you, Barry. Cheers. Bye.
Good day.